I will present about Chapter 1 Introduction. This chapter includes introduction of ABE and usage and application of ABE. Production of acetone, butanol, and ethanol was patented by Chaim Weizmann in 1913. In our production of ABE, we choose cholesterol as our carbon source. Glucose will react with amino acetate in the presence of Clostridium acetobacillum, undergo anaerobic fermentation, forming biomass, acetone, butanol, ethanol, carbon dioxide, hydrogen, acetic acid, butyric acid, and water. ABE is used and applied in manufacturing industry, cosmetic industry, laboratory industry, food industry, and medicine industry. Next is Chapter 2 Economic Issue. Economic issue include demand and supply of ABE, price of ABE, company producing ABE, future potential market of ABE, and plant capacity. Demand and supply. Based on the graph of supply and demand of ABE from 2021 to 2027, the future growth possibility across global market for ABE is rise at 4.8%. Higher CAGR is expected to be registered in Asia Pacific. The supply can reach up to 1.48 million kilotons in 2019. Price of ABE. This is the graph of global market of Asia Pacific from 2018 to 2025. This graph shows a promising growth of ABE pricing in the future as the price keeps increasing and showing a positive trend for the next upcoming years after it suddenly depleted in 2020 due to pandemic COVID-19. Company producing ABE are Songyuan Laihe Chemical Co Ltd, Habio Bioengineering Co Ltd, Green Biologic Co Ltd, Huabei Pharmaceutical Co Ltd, and Bangi Ltd. Our plant capacity is based on the demand supply by year 2022. Demand is 1.93 times 10 to the power of 6 kilotons per year. Supply is 1.7 times 10 to the power of 6 kilotons per year. So demand minus supply is 2.31 times 10 to the power of 11 kilogram per year. Production time per year is 8,400 hours. As our plant contribute 0.001 towards demand of ABE, our plant capacity is 2.31 times 10 to the power of 5 tons per year.
Let's talk about the next chapter, which is Chapter 3, Production of ABE. This chapter consists of two subtopics, which is Process Description and Process Flow Diagram. Process Description of ABE. As for raw material, we choose cholesterol for lignocellulosic biomass as it is a potential substrate to produce high yield of butanol. For pre-treatment of lignocellulosic biomass, in this process, it involves steam explosion, mixing, hydrolysis, filtration, separation, sterilizing, and cooling process. And for anaerobic fermentation of bacteria with glucose, it describes how the bacteria and its growth medium being cultivated. Apart from that, it also describes the filtration of products from the mixer and how the activated carbon works. Here, most of the water being eliminated. And last is for product. The product from the filter will then run through the distillation column to produce acetone, butanol, and ethanol. Let's move on to our next topic, which is Chapter 4, Environmental and Safety Issues. This includes three subtopics, which is safe handling of chemicals, waste generation, and environmental quality acts. As you can see on this slide, it shows 9 chemical substances that being used during the production. These are our waste product along with its recovery waste so that the waste product will also be fully utilized. Environmental and quality acts. There are few acts that being issued for ABE production. First is Act 127, the Environmental Quality Act 1974. It stated that there are severe laws and regulations in place to regulate emissions and cover air pollution. As for Environmental Quality Regulations 2009, and Section 29 of the Environmental Quality Act 1974 both highlighted the same thing, which is cannot release waste into any soil or source of water.
I will continue with Chapter 7, Cell Biology for Engineers. In this slide, I will explain about comparison of Clostridium acetobactericum with other bacteria and metabolic pathway of Clostridium acetobactericum to convert glucose into ABE. Clostridium acetobactericum is chosen as our selected cell to produce ABE compared with other two bacteria because it has a high use of ABE and it is non-pathogenic, but the other two bacteria is pathogenic and it has a suitable growth pH range and for the metabolic pathway. And this picture shows how the Clostridium acetobactericum to convert glucose into ethanol, acetone, and butanol. The next chapter will be presented is Chapter 8, Fluid Friction Loss. In this chapter, we draw a figure of P102 bump that is connected with main fermenter and mixer. Because we want to calculate the total friction loss inside this transport process. Hence, we do some calculation on the entrance and the exit of the bump. And we calculate for the Reynolds number inside this process, and we know the Reynolds number is more than 10 power of 4, and it means this turbulent flow inside the transport process, and we calculate for the total friction loss is 0.2367 joule per kg, and we use the mechanical energy balance equation to get the answer of shelf worth is negative 154.07 joule per kg, and the negative side means the work is done on the system. And we also calculate for the suction head and the discharge head friction loss and the head loss. For the suction head, we know the friction loss is 0.0962 joule per kg and the head loss is 209.87. For the discharge head, we know the friction loss is 0.2345 joule per kg, and for the head loss is 363.71 meter per second. And we also do the calculation in the performance rating of pump, and we know the efficiency of pump is 66.84%, and for the pump power is 1708.9603. And we also use all the data to draw the performance curve graph. Conclusion of IPR, demand of ABE in the world is high because the supply is not enough, and the process to produce ABE are fermentation, mixing, filtration, separation, heating, and cooling. And the waste produced in this process will be treated properly to avoid the pollution, and our plant capacity is 27610.9 kg per hour.